Hi. In this video, I am going to create a project on budget and expense tracking using SQL Server. We'll cover everything from database creation to analyzing financial data with powerful SQL queries. So let's get started. First, we need to create our database. Create database. Database name. That is budget tracking. Use budget tracking. Great. Now, let's create the required tables to store user information, expense categories, budgets, and expenses. First, I am going to create users table. Create table users. User ID integer identity primary key. Username varchar 100 not null. Email varchar 100 unique not null. Created date default get date. Now the users table is created. Similarly, we create the other tables with appropriate foreign key relationships. Now I have created the other tables. Here in the budget table, I have used on-delete cascade in category ID foreign key. Let me explain why I have used this. The on-delete cascade automatically deletes rows in the budgets table when a related row in the users or expense categories table is deleted. For example, if a user is deleted from the users table, all their budgets will also be deleted automatically. And similar. If a category is deleted from the expense categories table, all related budgets will also be deleted. Let me explain with another example. Delete from users where user ID is equal to 1. Since on-delete cascade is applied, this also deletes John's budget from the budgets table. Same I have used in expense table. Now, let's insert some sample data into our tables. Insert into users, username email. Values. John Doe, john.doe@gmail.com. Second record is Joni Smith, jjoni.smith@gmail.com. Third record is Mike Johnson, mike.johnson@gmail.com. Similarly, we insert categories, budgets, and expenses to populate our database. Now we have created 3 tables and inserted values inside the tables. Our next step is data modeling. Let's understand how our tables are related in our budget and expense tracking system. Before modeling, check all the tables that our values are inserted successfully or not. Great. The values are inserted successfully. Great. Now, let's move to understand the data modeling and relationship concepts. Go to your database, expand budget tracking. Database diagram, then right-click, New Database Diagram and add all the tables one by one. Let me do this. Here, you can see, the relationship between tables are created automatically. Let's understand the fact and dimension tables. Relationship type and coordinality. This is the summary of data model that I have created the entity relationship model for an expense management system that tracks users, their budgets, and expenses, categorized under different expense types. Let's break it down in detail. Users table. Each user can have multiple budgets and expenses. This is a one-to-many, 1M, relationship between users with budgets. and users with expenses. Expense categories table. Categories are used to classify both budgets and expenses. This forms another one-to-many relationship. That is, expense categories with budgets, in which each budget belongs to one category, and expense categories with expenses, in which each expense belongs to one category. Let's see the relationship type of tables. Here you can view the summary. The tables can be classified into fact tables and dimension tables based on a star schema approach used in data warehousing. Let me explain what is fact and dimension table. Fact table stores transactional data, measurable facts, such as expenses and budgets. Dimension table stores descriptive data, reference information, that provides context for facts. You can view the details in the metrics. Here is the complete data model diagram that I created in SQL Server. Here the data modeling steps are completed. Let's move to understand the next step of our project. So our next step is analyzing the data with some important KPI. We'll cover key financial metrics such as total expenses versus budget, spending trends, forecasting, expense breakdown %, budget versus expense trend, users with highest spending variability, and most frequent expense categories. Let's get started. First scenario is total expense versus budget. Let's run SQL queries to extract meaningful insights from the data. Select U.user name, C.category name, B.budget amount, sum, E.expense amount, 0, as total expense. B.budget amount, sum, E.expense amount, 0, as remaining budget. From budgets B, join expenses E. On B.user ID is equal to E.user ID. And B.category ID is equal to E.category ID. Join expense categories C. On B.category ID is equal to C.category ID. Group by U.user name, C.category name, B.budget amount. Let's execute. Some error are coming. Let me check the error. I forgot to apply sum. SP let me use sum function. And I need to join users table also. So let me join, and after that I have used comma in place of dot. Let me change and then execute. Great. The errors are fixed. Now let me explain it. This query retrieves information about users' budgets and expenses for different categories. It calculates how much they have spent and how much of their budget remains. If a user spends less than their budget, remaining budget will be positive. If a user spends exactly their budget, remaining budget will be 0. If a user exceeds their budget, remaining budget will be negative. Now let's move to the other scenario. Next scenario is calculate top 5 spending categories based on the total amount spent. Let's dive into the query and understand the results it produces. Select top 5. C.category name, sum, E.expense amount, as total spent. From expenses E. Join expense categories C on E.category ID is equal to C.category ID. Next scenario is calculate top 5 spending categories based on the total amount spent. Let's dive into the query and understand the results it produces. Select top 5. C. Category name. Sum, E. Expense amount, as total spent. From expenses E. Join expense categories C on E. Category ID is equal to C. Category ID. Group by C. Category name. Order by total spent descending. The goal of this query is to calculate the total amount spent in each category and display the top 5 categories with the highest total spending. Let's go through the key components of the query one by one. First, we are selecting 2 columns, category name from the expense categories table, and the sum, E. Expense amount, which will give us the total amount spent in each category. We join the expenses table with the expense categories table using the category ID. This allows us to match each expense to its corresponding category so that we can group the expenses and calculate the total spending for each category. Next, we use the group by clause to group the expenses by category name. Now, we use the order by clause to sort the results. Let's take a look at a sample result. In this table, we see the top 5 expense categories with the highest spending. For example, the rent category has the highest total spent at $1,200, followed by utilities with $600.5 and more. Now let's move to our next scenario, and our next scenario is users who exceeded budget. I have copied the previous query and going to change something, that is removing some unwanted details and adding some required details. Let me change and explain the whole process. Yes. Now query is completed. Let's go through the query and understand the results it produces. Select U. Username. C. Category name. Colas, sum, E. Expense amount, 0, as total expense. B. Budget amount. Case. When sum, E. Expense amount, B. Budget amount, then over budget. Else, within budget. End as budget status. From budgets B. Join expenses E. On B. User ID is equal to E. User ID and B. Category ID is equal to E. Category ID. Join users U on B. User ID is equal to U. User ID. Join expense categories C on B. Category ID is equal to C. Category ID. Group by U. Username, C. Category name, B. Budget amount. This query calculates the total expenses for each user and category, compares them against the budget, and categorizes whether each user is within their budget or over it. Let's understand the query. We are selecting the user name and category name. Next, we calculate the total expenses for each user category combination. Now, we pull in the budget amount from the budgets table to compare the total expenses against the available budget. The case statement checks if the total expenses for a user in a category exceed their budget. If they do, it flags the status as over budget. If not, it's flagged as within budget. This is how we categorize the budget status. The query uses join operations to combine data from multiple tables. The group by clause groups the results by username, category name, and budget amount. Let's take a look at a sample result. In this table, we see the total expenses, budget amount, and the resulting budget status for each user and category. Now we'll be analyzing an SQL query that calculates the total expenses for each month based on a given set of data. Let's break down the query and see what results it produces. Select Format, Expense Date, YYYYMM as Expense Month. Sum, Expense Amount as Total Expenses. From Expenses. Group by Format, Expense Date, YYYYMM. Order by Expense Month. This SQL query is designed to summarize expenses over a period of time, grouped by month. Let's go through each part of the query step by step. The function format, expense date, YYYYMM, is used to extract just the year and month from the expense date column, which will be labeled as expense month. This allows us to group the data by month, disregarding the exact day. Sum function to calculate the total amount of expenses for each month. This is done with the group by clause, which ensures that the expenses are aggregated into distinct months, based on the formatted expense date. If you have expenses that span multiple months, like January, February, and March, this query will separate them into their respective months. Finally, the Order by Expense Month clause sorts the results in ascending order by month. Let's take a look at the possible output. This table shows the total expenses for each month. In February 2025, the total expenses were 1,550.50. In March, they rose to 500.50. Our next KPI is budget utilization percentage, in which we have to calculate how much of the allocated budget has been spent. Let's dive into the details of this query and understand the results it produces. U.username, C.category name, B.budget amount. Coles, sum, E.expense amount, 0, as total expense. Round, coles, sum, E.expense amount, 0, divide by B.budget amount, into 100,2, as budget utilization percent. From budgets B. Left join expenses E. On B.user ID is equal to E.user ID and B.category ID is equal to E.category ID. Join users U. On B.user ID is equal to U.user ID. Join expense categories C on B.category ID is equal to C.category ID. Group by U.username, C.category name, B.budget amount. Let's execute to see the result. Let me fix the error. Let me correct the spelling of Coles. Let's go through the key components of the query step by step. First, we are selecting the following columns: the username from the users table, the category name from the expense categories table, and the budget amount from the budgets table. Then calculate the total expenses for each category and user. But what if a user hasn't spent anything in a category? This is where Coles comes in. It ensures that if there are no expenses for a user in a given category, the result will be 0 instead of null. Then calculating the budget utilization percentage. This is done by dividing the total expenses by the budget amount and multiplying by 100. We also use the round function to ensure the percentage is displayed with 2 decimal places for clarity. Let's look at the join operations. The left join between the budgets and expenses tables ensures that we include all budget records, even if there's no matching expense. This way, we'll still show a budget record with 0 expenses when necessary. The other join clauses connect the budgets table with the users and expense categories tables to pull in the relevant user details and category names for the result. The group by clause ensures that we group the results by each unique combination of user, category, and budget. Let's take a look at a sample result set. In this table, we can see the username, expense category, the total budget for that category, the total expenses, and the calculated budget utilization percentage. For example, John Doe has a budget of $500 for groceries, but has only spent $120.5, which gives a budget utilization of 24.1%. And similar to others. Now let's move to the other KPIs. Next KPI is category-wise expense breakdown percent. That is what percentage of total expenses is spent in each category. Let's write the query. First, we start with a common table expression, or CTE, which is called total expense. With total expense as select sum, expense amount, as overall expense from expenses. This CTE calculates the total sum of all expenses in the expenses table. Select C.category name. Sum, E.expense amount, as category total. We are selecting the category name from the expense categories table and calculating the total expenses per category by summing the expense amount for each category. Round, sum, E.expense amount, divide by. Select overall expense from total expense into 100,2 as expense percentage from expenses E. Then, we calculate the percentage of the total expenses for each category. This is done by dividing the total expenses for each category by the overall total expenses, and then multiplying by 100 to get the percentage. We use the round function to ensure the percentage is rounded to 2 decimal places. Join expense categories C on E.category ID is equal to C.category ID. Group by C.category name. We join the expenses table with the expense categories table on the category ID to link each expense to its respective category. And then finally, we group the results by category name so that the total expenses and percentages are calculated for each individual category. Let's execute to see the result. As we can see, the query calculates both the total expenses for each category and the percentage that category contributes to the overall expenses. Our next KPI is monthly budget versus expenses trend. That is tracking spending over time compared to the budget. Let's take a look at the query we are working with. Select format, E.expense date, YYYYMM as expense month. Sum, E.expense amount, as total expenses. Select sum, budget amount, from budgets where budget month is equal to format, E.expense date, YYYYMM01, as total budget. From expenses E. Group by format, E.expense date, YYYYMM. Order by expense month. This query is designed to provide a report on monthly expenses and the corresponding budget for each month. We are working with 2 tables here, expenses and budgets. First, we use format to extract the year and month from the expense date column in the expenses table. Next, we use sum, E.expense amount, to calculate the total expenses for each month. This gives us the total expenses per month, which will be shown under total expenses. Here comes the more complex part. We are using a subquery to calculate the total budget for the same month. We compare the budget month from the budgets table to the expense month we just calculated using the same format function. Then, we group the data by expense month using group by. This ensures that each row of the result corresponds to 1 month. Finally, we sort the results in ascending order by expense month with order by. Now let's execute to see the result. Some error is coming due to month format. Let me fix it. Let me change the format query in where clause. Format, budget month, YYYYMM, is equal to format, e.expense date, YYYYMM, as total budget. Let me execute again. Now the query is fixed. Let me explain. We can see the total expense in February 2025 is 1550.5 and total budget is 2350 and total expense in March 2025 is 500.5 and total budget is null. Here null is coming because there is no budget in March 2025. Let me check the budget table. Here you can see the budget amount is available for February 2025 only and no budget for March 2025. Now let's move to our next scenario. That is average daily spending, in which we have to calculate what is the user's average daily expense. Let's write the query. Select u.username, round, average, e.expense amount, 2, as average daily spending. From expenses E. Join users U on e.user ID is equal to u.user ID. Group by u.username. The final result returned each user's average daily spending, and this can help us understand their typical spending behavior. Now, let's look at the second query, which identifies users with inconsistent spending habits. In other words, we want to know which users have the highest variability in their spending. Let's write the query. Select u.username, round, stdev, e.expense amount, 2, as spending variance. From expenses E. Join users U on e.user ID is equal to u.user ID. Group by u.username. Order by spending variance descending. This way, we get a ranked list showing the users with the most unpredictable spending habits. It helps us identify users whose spending habits are more inconsistent, indicating high variability. In our next scenario, we learn how to forecast future spending using a moving average. Let's get started with monthly expenses as select format, expense date, YYYYMM as expense month. Sum, expense amount, as total expenses from expenses. Group by format, expense date, YYYYMM. Select expense month, total expenses. Round, average, total expenses, over, order by expense month rows between two preceding. And current row, 2, as moving average 3 months from monthly expenses. Let's understand the query. We are creating a common table expression called monthly expenses. In this CTE, we are formatting the expense date into a month and year format, YYYYMM. Summing up the expenses for each month to get the total expenses. This gives us a summary of the total expenses for each month. Now, in the main query, we are calculating the 3-month moving average of these total expenses. To do this, we use the average function combined with a window function, but only considers the current row and the previous 2 rows, that is the last 3 months. Lastly, we round the result to 2 decimal places for clarity. Let's execute to see the result. In the result set we can see month-wise total expense and moving average. In March 2025, the moving average is 1025.5, which is the average of February and March. Next, let's look at another useful query that helps identify which expense categories are used the most. Select C.Category Name, Count, E.Expense ID, as frequency. From Expenses E. Join expense categories C on E.Category ID is equal to C.Category ID. Group by C.Category Name. Order by frequency. In this query, we are analyzing the frequency of each expense category. Here's what's happening. We join the expenses table with the expense categories table using the category ID. Then, we count the number of times each category ID appears in the expenses table, which gives us the frequency of expenses in each category. Then, we group the results by category name to see the count for each category. The order by frequency at the end sorts the categories from most frequent to least frequent, so you can easily spot which category is used the most. Let me execute the query. This result helps to identify which categories are being used the most. In this video, we've walked through every step of building a robust budget tracking system using SQL Server. We've designed databases, implemented queries, and defined KPIs to measure the success of our budget tracking process. Now that we've completed all the key performance indicators. In the next video I will cover this project using Power BI. Thanks for watching.